Hi guys, Mr. Bennett here. Now we're going to be looking at cubic polynomials. Now we're going to be factorising these, and it's not going to be much different from what we would do if we had just a normal quadratic. So let's have a go at a couple anyway here. So the first one here is it's a cubic polynomial, but I can see quite clearly that there is an x term in every one. So what we're going to do is bring out a common factor of x. So if we do that, that will leave us with x squared plus 4x take 21. Now you've got all your techniques that you can use for factorising. I can quite clearly see that x squared has to become x and x, and 21 really there's only two examples, which is 21 and 1 and 7 and 3. So I think it has to be 7 and 3. And because that's plus, the big one has to be the plus one, that has to be minus. So if we were factorising that, the factors, when that's equal to 0, x is going to be equal to 0, or x is going to be equal to 3, or x is going to be equal to 7, minus 7. Alright, so we've now found the factors. Now, remembering what that means is with this particular information here, these are in fact the x-intercepts. Alright, so if we're looking at that, minus 7, 0 and 3, 0 and 3. Now if we did the sign diagram for that, that would tell us if it's above or below. Alright, and we could get an idea of the shape of the curve from that. Alright, so that's the sort of thing that we would do if we were really interested in graphing the information. We'll do some of those afterwards. Now this second example is one where this is the sort of thing that you would most likely see in a test. Alright, so we're being told one of the factors is x plus 4, and we've got this polynomial, and we're wanting you to do this by hand. So really what I'm going to say here is x plus 4 is a factor, and I'm going to think of a general term. So ax squared plus bx plus c. Now that has to be equal to the polynomial over here, 2x cubed plus 5x squared take 21x take 35. Alright, so I'm thinking about here for my a value. What will I need to times x by to get 2x cubed? Well, a must be, in this particular case, a must be equal to 2x. So I'll get x plus 4. So this here must be 2x squared. 2x squared plus x gives me 2x cubed. Beautiful. What must I times the 4 by, the plus 4 by to get minus 36? Well, that must be minus 9. Okay, for that to be the case. And so therefore, I've now got two of those terms. The only term I don't know is the b term in the middle. Alright, so if I now just keep that as a b term, and we now expand that out, we're going to factorise that. So I'm going to get x. The easiest way to factorise this particular term is to times x by every term and then the 4 by every term. So that's going to be 2x cubed. X times by b is going to be plus bx squared. X times by minus 9 is minus 9x. Plus 4 is going to be plus 8x to squared. Plus 4 times by bx is plus 4bx. And then we've got the last term is minus 36. Alright, so now we're going to collect some like terms. Alright, so just might make my equals over here. Didn't give myself enough space. So I've got my 2x cubed. I'm going to collect my like terms. So I've got plus b and plus 8. So I've got simply 8 plus bx squared collect my x terms together, I've got plus 4b and minus 9x, and then I've got my minus 36. Alright, so looking at that, we can now equate some things together. Alright, so if I'm looking at this particular number there, 5, that has to be equal to this bit here. Alright, so that's what that has to be. And this term here, the minus 21, has to be equal to this term here. Alright, so it's obviously going to be, we can do it by lots of different ways, but the easiest way would be to say something like, well, 5 has to be equal to 8 plus b. So therefore, b would have to be equal to minus 3. Now I can check that with my next term. If I had 4 times by minus 3, and then I have to take 9 away, that should give me minus 21. And that does. So therefore b is equal to 3. So therefore, if I have to find all my factors, then what I would be doing there would be simply saying, this next bit is therefore x plus 4, 2x squared, take 3x, take 9. Right, so I've already got one of my factors. Now, really it comes down to factorising a quadratic, and that's what all of these things do, and that's why the factorisation of quadratics is so important. So x plus 4, well, I know 2x is going to be 2x and x. I know 9 is going to be either 9 and 1 or 3 and 3. I'm thinking 6 and 3, so it's going to be 3 and 3. Alright, so therefore, if I'm looking at that, I know it needs to be minus 3, so that has to be the minus, and that has to be a positive. Alright, so if you expand that out, you're going to get the right values there. Alright, so therefore, factors of this particular thing are going to be x equals minus 4. And when that is equal to 0, it's going to be minus 3 on 2. And the next one's going to be at 3. Alright, so I've now factorised. Now, I'll just recap the key things there. The key thing is to, and I don't even really need to write that term there, but generally what I'm doing is I'm timesing by a quadratic. So the two terms that I look at, the most important terms, are the first term there and the last term there. Alright, so I'm looking at that term and I'm looking at that term there. They determine two of my values inside the bracket, and then I keep my unknown term, which is my bx. I expand it out, and then I equate the two terms together. That make it easy for me to work it out. Right, bit of practice for you to have a go at doing this, and if you need some help with it, make sure you ask myself or Mr. Boyle.